Drago mi je da se opet skupljate u priličnom broju, još ljudi dolaze. Molim nekoga gore ako može samo zatvoriti vrata, pa da možemo u tišini nastaviti. Good morning everybody. Our first speaker today is well-known Aaron Saigo. He will talk about art of the software development. Okay, you can start.
Good morning, everybody. So, first of all, thanks to everyone who's helped organize the event. It was fantastic. They also gave me this beautiful tie yesterday, which someone asked me to promise to wear it today for my talk. So, a promise is a promise. Here I am. This is not my defective sense of fashion. So, we're going to talk today a bit about Go and the art of software development. Why would I be up here talking about software development and the art of it, and why should you listen to me? Probably you shouldn't. Just give a bit of background on myself. My first software development job, full-time, was in 1992, because I'm old. Time does not, on its own, give oneself the qualification to speak on these topics. I've known people who've been working in software for 15, 20 plus years. Hello, Hans. Everyone say hello to Hans. It's a tradition now. It's almost right. I've written software for stock exchanges, for financial risk management. You probably know me from perhaps some of my work with the KDE community, with Plasma. The concept of convergence was first developed and demonstrated in the KDE code base. If you see the car outside that is running beautiful UI with cute QML, I worked with Trolltech for many years and actually was tangentially involved with QML development in the early days. Worked at Nokia, did original product development there for a few years as well. So I've done a few things, and there's some things that I've noticed about software, especially in the last some years, and that is software is not nearly as good as it could be. And we really have no one to blame. How many people here are software developers? How many people write software? All right, so it's our fault. That's not as good as it could be. I actually read a blog entry about a week ago, and it was a guy, and he just got so upset about how bad software is that all he did was, for a month, he took a screenshot of every time he encountered an error in a website or local software. And I mean, this blog entry was long. And he's like, why do we have so many, why is everything so broken and so fragile? Why don't things work? So I want to talk about Go, to change the topic slightly. How many people know or have played Go? Good morning. Cool. How many people know the game of Go because they recently saw the Google Deep Learning beat the world-class Go person? Okay, a few of you. So for those who have never seen Go before, it's this is the game. It's an Asian game. You played in China, Korea, Japan. It is a fantastic game. And if I was to try and explain the qualities of Go, I would say that Go is simple, and we're going to see how simple it is, but it's multidimensional despite the simplicity, and it's really difficult to master, which kind of sounds a lot like software, writing it. It's simple, you have ifs and whiles, and yes, assignment to variables, that's not too difficult. But as you start developing larger software projects, you realize just what a difficult problem creating good software can be, and it is pretty difficult to master. So when I say that Go is simple, here are all the rules. It's really simple. It's a 19 by 19 grid. You have two players. One is black, one is white. You take turns putting stones on the intersections, the crossing points of the lines. A stone is alive if it has at least one open intersection next to it. It's called liberties. Stones that are next to each other are connected, and they share their liberties. And after you place your stone, if you've managed to completely surround the other player's stones so that there's no liberties, no empty spaces, you remove them. That's it. That is the entire game. And you play until both players pass one after the other. There's no real set end. You just supposed to agree, we're done. It's a very simple game. The only weird or interesting rule is that a play is illegal if it would recreate the previous board position. It's just a prevention against infinite looping. Hello, Turing. This is what a game looks like once it's fairly well established. So you can see this is a liberty to this guy. Here's another liberty to him. These stones are connected, so if there was a stone here, here, and here, and here, these would go. And these very simple rules start developing or have a lot of implications. So there's that black group there, and it's safe. There's no way to actually, unless the black player really screws up, there's no way to completely remove those, because it has, well, could have and would have very quickly, if white played in there, 2 eyes, which is 2 empty circles that it completely surrounds. So there's a lot of really interesting strategy that comes out of it. It's actually why it took so long for humanity to build a machine that could play it well, because despite being extremely simple, there's a lot of emergent complexity. So a quick ramble about the nature of Go, and one of the reasons I really love it, besides that you get this like amazing complexity from a simple game, is that it has a lot of things that we all know and love from computer science. It's a graph, if you look at the connected stones in this way. It's concurrent. We'll talk about how it's concurrent in a bit. It features immutable state. You don't move your pieces. You place new ones. The state never changes. You can only add to it. And it's kind of got garbage collection, because as soon as a bunch of stones are surrounded and can no longer play and can't do anything, they just get pulled off the board. Well, that's not really what we're going to talk about. Just, I think, some interesting observations about Go. So I want to take 2 different things about the game of Go and reflect them back on how we make software today. One of the very interesting things about Go is that it's both tactical and strategic at the same time. You have a local context and you have a global context. And if we go back to that board really quick, yeah, there we are. If you've never played the game, it just looks like a mess of stones. If you have played the game, you'll probably immediately look at this, and it's actually a fairly complete game. In fact, they may have both passed to this point. But you will pick out areas where there are local battles happening. Here, up there, over here. And when you're playing, where you decide to actually place your stones, which of these localized challenges and battles back and forth that you decide to engage with, because you only place 1 stone at a time, has to do with what your global strategy is. And when you start a game, you often put your stones as kind of randomly, what looks like randomly, but it's not, around the board, and it's very, like, the first few games you play, like, what is going on? Because you have these competing contexts. You have to both play well tactically at the local level, and you have to have a very good strategic viewpoint at the exact same time. I find that in software that goes wrong, one of the things that is almost always apparent is that this kind of thinking, the ability to focus simultaneously on the local problem, but also keep your head on the global issues of the software writing, is missing. So software is really a big picture built out of really small pieces. Just like the game of Go is a big game made of a whole bunch of little struggles and little battles going on the board. So when I write software, I try and ask myself these questions. Not only these 3, but these are 3 that I ask myself. What sort of whole do the pieces create? We hear a lot of people, or you can find a lot of material about, best algorithm to pick, or different ways of implementing specific things in your code. But rarely, and we have the patterns books, which are pretty interesting. You have the anti-pattern books. But rarely do we really think about that. What is the whole that we're making out of these little pieces? At the same time, are we focused on the right local challenges? Right? So, as a software developer, you'll have heard, no doubt, probably repeatedly, don't optimize until you've measured. Right? And that's really about, are you focusing on the right local problems? Because if you just try and guess and optimize something randomly, it probably is not going to make a big change, so you measure first. And that's really interesting that these 2 questions sit next to each other. Where should I be focusing my attention on the local pieces, and how do the local pieces form a greater whole? And that leads to the question of, well, after I'm done this, what comes next? And this is really, I think, a hugely important philosophical way of looking at software, because often when I find problems in software, it is because one of these 2 things is missing. There's either a bunch of really nice collections of small pieces that don't really fit together, or you have something that has kind of a big picture view, but the implementation inside of it is just horrific, and you end up running into a wall. So this local global simultaneous is really important. The other scoping issue with software today is that we rarely run software in isolation. I thought it was really interesting, the car, to pick on the car again, the car presentation the other day where it had like this really nice layout of all the different pieces that work with each other. And if you go and look at the demo booth, it actually has two different displays, and there are actually two different systems with different input and output devices, different use cases, and they're supposed to work together, and they work with other pieces inside. Most people who write software these days are writing software that ends up working with the network. It either is on a server or it connects to an online service. So almost none of our software is an island anymore. It's a local node in a very big world. Do we have web developers in the house? Who's a web developer? Okay, cool. So you guys especially, you're a local node in a very big world. And disturbingly enough, we don't really take advantage of that very well, because very few pieces of software present a consumable interface, by which I mean, can another piece of software that you haven't even thought of yet be able to use your software to do something else? Does it provide an API that can be reached? API design is horrifically difficult, and especially on the web, I find it's done wrong almost all the time. And I'm not going to get into, that's a 2 or 3 hour presentation about interface API design, but this question of, are we building software to be consumed? Is it composable? By which I mean, can you take that piece of software, another piece of software, and realistically put them together? Or is it so, are the internals so exposed to the outside that the outside is really just a reflection of what's happening inside? It becomes brittle, it doesn't have an exposed API of any real use, so the functionality is cut away from the world, and you can't compose it together with other pieces. When, let me see, back in, I guess, the early 2000s, you used to call them mashups on the web, right, where you take two different things, you put them together, and you get a third thing, and it's awesome. You put web maps together with local information on club performances, what bands are playing. Oh, cool, mashup. This composability, I'm seeing less and less and less, both in mobile software, where it's a very difficult issue, but also on the web and in even desktop software. And this really limits what we're able to do with it. And then the whole question of, is it concurrent, is it scalable, is it federated? Are we really taking advantage of the fact that we have a global network of multiple devices that who here has only one computer with them right now? Because most of you have probably a smartphone. I see a lot of people have laptops. I've got 3 or 4 with me, I think. We don't really think of it that way, but we're a walking small network of ourselves, or on our own. And is our software designed to take advantage of that? And if not, why? And what opportunities are we missing? So the moral of the story here is, when we focus on meeting the requirements that are only directly in front of us, we risk creating dead-end technology. So we invest a lot of time and effort into making something that gets used once in one place and doesn't actually make something bigger. In Go, if you play this way, you lose every time. If you just focus on like one area of the board, and I'm going to win that corner of the board, you're going to lose because the other guy's going to go, fine, you have that corner of the board, I'm going to go take the rest of it. And similarly, with software, this is not a great strategy for building robust and interesting software. And one of the most, I think, interesting sides of the network effect, this local global attribute of software development, is that our software isn't only the thing we write. It's also an advocate of the tools that are used in it. And so again, these questions, do I consider the impact of the choice in tools that I make that go beyond my own project? Will my software help others choose great technology as well? And are we supporting technology that supports freedom? So what do I mean by those questions? Like, what's the point of those? So I'll use an example. Who here has used the MySQL or MariaDB database in a project? Yep. Yeah. How many people have used PostgreSQL? Okay, that's so cool. So if you go back like 15 years, it was like, if you ask who's used MySQL, everyone hands go up. Who's used Postgres, and like 1 or 2 like hardcore geeks from the BSD world would put their hands up, and they would glare at the people who use MySQL. And it was really interesting because a lot of tools were built specifically or only for MySQL usage on the web. And MySQL is actually a really horrible database. It teaches you all kinds of don't do this things with databases. And so the frustrating thing for a lot of us in software development was we would constantly come across people who had these like really strange ideas about how you use a database. Like, as we talked about the other day, stored procedures, you don't need those. You just handle your referential integrity in your application code. Oh, that is so wrong-headed. But this was something that became part of the wisdom of web development a few years back, because MySQL had a limitation. It wasn't really good at that. And so there's like, yeah, you don't need it. Just trust us. That would be okay if it wasn't for the fact that everyone was using MySQL and was encouraging other people to use MySQL. And they're like, well, I've used it, you use it, I read your code, he's using it, cool, there's all these tools to use. And so we ended up with a ton of really horrible code using really horrible databases. We're still living with that today. So the tools we use in our software will not just be living on in your software because we share tooling now. The days when we designed the entire software stack from the bottom up, that died 40 years ago, right? It's all about really reusable components, even if it's not at the level that the object-oriented crowd thought it would be. It's really at the level of individual services like database servers and whatnot. So when we design the software, the moral of the story is we are making decisions not only for ourselves, but we're accidentally making decisions for others just by encouraging them. And so we're picking winners and losers, really. And so I think as technology creators, we need to think really hard about, if I put my energy behind this technology, is that going to be a good thing in 10 years, or am I kind of letting myself and my fellow developers down? You're never going to get it right 100% of the time, but if we think about it, we'll get it wrong less. Okay, so the second aspect, so there we go. We're going to take away the whole concept of Go showing us that local and global must be held in our minds at the same time. And we're going to move to the other really fascinating aspect of the game of Go, which is it's so simple. Like, any one of you, after I've shown you those rules, could actually play a game. Probably not very well if it's your first time, but you could play it. You can teach someone to play Go way faster than you can teach them to play chess. And yet, chess is a vastly simpler game than Go is. And to really get good at Go, and I'm not really good at it, I'm passable maybe, it takes a lifetime of to master it. And you don't memorize, openings and defenses and these kinds of things. You're actually looking and trying to understand what's going on the board, which is also why it was hard for a computer to play. So I'm going to give you a couple of things that have really helped me grow in the last 30 years of doing this. And it's things that I wish people had told me a long time ago, because maybe I would be a better developer than I am now. So first of all, software development is just like Go. It is simple. You can teach an 8-year-old to do it. I was plonking away on Apple IIs and PETs and Commodore 64s. This was not a problem. I was a little kid. It's simple to do, but to get really good at it, it takes a lifetime to master. And I don't know about you, but I love the idea of craftsmanship and the idea of being good at what you do. It's a very satisfying, both the journey and the results are very satisfying. So, how can we do that? First thing I would recommend is try a big thing, a new big thing every year. Step outside your comfort zones. There are people, I know lots of developers who are like, they're Java developers. And really that's all they've ever done, right? And that's okay, that's a choice. Other people are like, oh, I work with PHP and that's really all I know, and everything else, and I haven't really tried anything. In our office, we encourage people to try new things. We hand around new frameworks, new concepts, bring videos in for people to watch. And the whole point is that if you try at least one big new thing every year, a few things are going to happen. I mean, you're going to learn something new, that's cool. You may never use that tool, right? It may be something you just play with, you make some small project in it for yourself, and you're like, never touch it again. But you're going to understand the strengths of what you do use on a regular basis much clearer by comparing it with this other thing you've used. You might also learn something completely new and different, right? Functional programming is something that's becoming really popular now. It's making its way into all the mainstream languages. You see the new C++ drafts, you see what's happening in Java, you see there's lots of functional programming now, or bits of it anyways, in Python, Ruby from the beginning, really. How many people here have written a project more than, say, 5,000 lines of code in a functional programming language? Yeah, very few, right? That's just one thing. You go, well, let me pick up a functional programming language. The other day we were talking about Erlang briefly. That's a really neat language, and Elixir as well runs on the Erlang VM, because it also introduces the concept of concurrency through immutable state and having green threads, or green processes really, so non-OS native process. And that's just like, when you work with that, it's like, wow, that's such a different way of thinking about decomposing a problem. So even if you never use that thing you've tried before, you're going to understand your craft a lot better, and you're probably going to come away with some really different ideas. If nothing else, you might try it and go, holy, that was horrible. And then you know what not to do. So no matter what it is, you're going to come away a better, more seasoned developer. Really try something new that's big every year, whether that's a framework, whether that's a language, whether it's just a technique. Immerse yourself, expand, grow. And you can help yourself doing that by exposing yourself to other ideas. Sometimes I'll mention in conversation, because it's true, I have read through the code of programs like Apache, PostgreSQL, OpenSSH. I just enjoy it. It's really interesting to look into the minds of other people that write code, especially code I respect, and go, well, what are they thinking, and how do they do it, and what works for them, and also see that when they make kind of like weird decisions, and you go, wow, why do they do it that way, and try and figure it out. This is, I think, a really important skill, not only because reading code, the more you read code, the better you're going to get at it. And there's no better way of debugging something than understanding your code, because you look at what the debugger says, but you still have to map that to your code. And oftentimes, if you're really good at reading code, you can say there's a bug here somewhere, you look at it, and you mentally process it. Linus talks about this quite a bit. In fact, that was why a debugger in the kernel took forever to go in originally, because he's like, nope, the proper way to do it is to understand code, not rely on a debugger. I don't agree with him. I'm not quite that strict about it, but being able to read code well is really important. But most importantly, you're going to see ideas that would never occur to you. And that's the beautiful thing about having free software everywhere, is we get to look at the products of some of the most brilliant developers in the world, and they're just sitting there in Git repositories, just waiting for us to open it up, take a look, read it, right? So instead of reading a book, maybe read some source code. And when I mention that I do this, oftentimes, even at development conferences, people will laugh and chuckle like I'm some sort of eccentric person. But I think it's really important to do. I know it has definitely helped to improve my own ability to code. And then finally, this is perhaps the most important thing, use what you learn. So many developers, even if they do try new things and play with new things at home and are on their spare time, or maybe take a little bit of a sabbatical, they come back to work and they do the exact same thing they've always been doing. Even though they know more, they're not applying it. We see the same patterns again and again and again and again in software. Even though it didn't work the first time, the 10th time, the 100th time, people still do it. Why? Not because we don't know better all the time, sometimes we don't, but often it's just because people don't apply what we've learned. We show up, we write code, we don't really care about what happens, we just do it the same way we did it last year, the same way we did it 5 years ago, and the result is we get really shitty software that doesn't have to be that way. But these three things, these are not things you do once, they're things that you take through as a practice. The things that you do for your entire life as a developer. I think that's as equally true for any craft, by the way. It's not just software development, it's whether you make wooden cabinets for kitchens or you do DevOps or whatever. So when I look at this board, this game of Go, this messy, amazing, beautiful, emergent complexity, what I see here is that we can do a lot better with the software we write if we just looked at what's in front of us and thought about what we'd actually like to make. Thank you. So, questions? We've got like 5 minutes. Try and always leave a few minutes at the end so people can harass me and pester me with questions. Not
no
everyone.
Questions?
I don't
You're
believe
shy?
that.
It's too early, huh? Okay, I'll crash the ice with the question.
Yep.
Where do you see Go in the industry? Where is it applied the most?
The language?
Yes.
Okay. I hope it would die and burn and go away. It is a horrible, horrible... So when you have the opportunity to create a new language... So I love the game Go, but the language is a... So when you have the opportunity to create a new language, what would you not do? I think what you would not do is go, let's take a look at a API that was invented 40 years ago when we really didn't understand about APIs, when people were writing to very limited hardware, so you had to really expose the hardware, so, which I'm referring to libc mostly. And people have come to love that C library, and they learn it and they know it and they can, you know, code with it in their dreams. We all know these C developers. Can't take C out of my cold dead hands. So what Google does is they're like, yeah, we need them not to be writing C anymore. Well, how do we get them away from it? Because we can't pry their hands off that goddamn API. What do we do? So they created a whole new language, which has some neat ideas about concurrency that are done much better in other languages, by the way, that is more safe to use, also done better in other languages that I've used. But then they inject the stupidest 40-year-old API so that the old C developers are like comfortable with it. And I really think that's what would happen. I think Google just wanted their developers who refused to change and refused to learn new things, something that was better but familiar. And so in that sense, I think that unless you are a crusty C developer who just can't get yourself beyond what libc looks like, go ahead, use Go. Otherwise, there are infinitely better options out there. So, not that I have a strong opinion about anything.
Okay, now that you told us what you think about Go, can you tell us what you think about Perl? And keep in mind that I really love that language.
So, yeah, Perl. Okay, I have a soft spot in my heart for Perl. One of my very first companies was a company that wrote a website. It was way back when web was just starting, 1996 or something like this. And it was this little bit of Perl you could put on your server, and it did statistics for visitors, you know, geographic breakout and whatnot. And because we wanted it to have zero dependencies, I wrote a little small, like, queryable database in Perl, and fantastic. I think Perl is everyone says it's a write once language, right? And it looks like, once you know it, and this is really about craftsmanship, once you know it, you read it and go, oh, I can understand that completely. It reminds me a lot of archaeologists who look at cuneiform tablets from like Sumeria, and I can't even see like where the lines are, and they're like, oh yeah, so this says that so-and-so ordered some goats, and he wanted some corn, and he got some of that, and he made some beer. It's like, well, it's amazing. And Perl's the same way, it just takes practice. But I think Perl is a really good cautionary tale as well. This is going to sound like heresy. I loved Perl 4. Perl 5 was when I went, I'm done, I'm good, thank you, bye-bye. And then Perl 6 happened, I was like, what? I mean, it's a different language. I have this theory, and in one sense, Perl 6 is kind of cool in this way, but I have this personal philosophy that every language should be allowed to have like 4 major releases, and then its developers, its main designers, must be forced to do something different. Like, just stop screwing with the language. It's done. Because every language that goes beyond those first, like, 4, maybe 5 releases, it becomes a mess. Have you seen what they're doing with C# now, right? It's just like this amalgam of, like, crazy-ass ideas. Java 8, C++. I love C++. I write a lot of it, but good God, can we stop adding to the language? And what happens is that developers, they look at their language and go, it's a thing of beauty. What can I, and this is the same thing with frameworks, too, by the way. Stop developing things when they're done. There's nothing wrong with software being done. So they look at it and go, that's beautiful, what's left to do? And they look around, and they get kind of bored, and they go, that's a shiny, cool idea, I'm going to add that. And you're like, but that just makes no sense. To add that to this other thing that's a completely different concept, you're just going to make a confusing mess. Now there's going to be 5 ways of doing things instead of 3. You're going to be changing kind of the rhythm of the whole thing, but they do it because they have nothing else to do. So just keep adding to it. So I love Perl. Soft place in my heart, but I think it's a really good example of a language that just should have been left alone, because it was beautiful. In that sense, it's kind of cool they did Perl 6, right? I kind of look at it and go, Perl 5 has been left alone, and now it can just mellow in its old age and be a happy thing. Anyone else have a language they want me to rant about? Or a framework, if you want me to rag on those as well.
Yes, we're doing a lot of work in PHP, and our projects are
Apologies.
We're getting our projects are getting extremely large and complex. So we are obviously looking into something else, and we are naturally looking into Java. But you have a lot of people saying, no, don't do Java in 2016. Do something else. I was looking at Scala and the functional programming stuff. Should we learn Java today? or should we possibly do something else?
So that's actually two questions. One is, should we learn Java because I want a job? And there's tons of Java jobs, so if you're in it to get a job, go ahead. If you're wanting to learn a technology to do something good, I mean, Java was a really cool idea. I don't know if you know, but originally it was designed to allow mesh networks to come together, and it was supposed to be this little thing. It was called Acorn before it was called Java, and it was supposed to like allow you to put a whole bunch of devices together, and they just swarm into a network, and that was part of the reason why you had to share code in a CPU independent way. And then Sun was like, but we can make money with this on the web, and then everything was downhill. But it was a really good first attempt at trying to make a complex object-oriented system, and they fell into a lot of typical traps, like let's build a gigantic hierarchy of a tree of objects and classes, and it's old and it's not necessary. There's much better things out there. I'll make a recommendation, and you can maybe look at it and you can disagree, that's okay. That's what this is all about. But for web stuff, I mean, okay, what is the web? The web, you want dependable latency, so you know what your performance is going to be. You want something where you can do, you can interleave I/O a lot. I mean, that's what Node.js's claim to fame is, but it's a mess because they don't know how to do package management. You also want to be able to occasionally do some heavy lifting processing, perhaps. You need something that's going to always stay up and not fall over at the slightest breeze of an error in your code. You're going to want something that's distributable, because you're going to want to be able to cluster it easily, right? And you want it to be safe. So there's a really, really, really good framework right now. It was actually co-designed by one of the guys who co-designed Ruby on Rails, who realized that Ruby inherently has limitations that he couldn't get around. He needed to make something new. But he liked the ideas of a focus on quality, a focus on testing, a focus on high productivity and clarity and cleanliness and beauty. And so he did Elixir, which is that language I mentioned earlier. It runs on the Erlang VM, and you get concurrency, you get no downtime, you get clustering out of the box, completely transparent to you. You get you can do both I/O based, but also hard lifting calculations, which Node is not good at, without thinking about it. It just does it, handles that all for you. And on top of that, there's this beautiful web framework called Phoenix. It's phoenixframework.org, .net, something. Google will tell you, I'm sure. And it's really pretty. It's like Ruby on Rails done, it's done the second time, and this time really nicely done. Writing code in it is fast and quick. The results are really good. It's testable. It's got built-in testing, built-in documentation. You get to use all the Erlang libraries underneath it. There's just like closure on the Java VM, for instance, you just call back and forth, no problem. And there's like a bajillion libraries for Erlang. And you know it works because Erlang is what over 50% of the world's GSM traffic runs on. It's battle tested, tried and true. So it's got that really nice intersection of exactly what the web is all about. Servicing hundreds to millions, depending on how lucky you are, people with one code base that you can scale out horizontally. And be safe about it. Ecto, by the way, the included database, it's not an ORM, thankfully, but it's this beautiful abstraction over databases that's just gorgeous. Take a look at that as well. It's pretty much my time, I think. They're probably going to kick me off in a moment. Stop ranting, go away. So thank you very much for your attention. If you want to talk afterwards, I'll be here as well.
He has the original, genuine creation tie, as he promised. So give him another great applause.